Transformers in production. Best practices explained. Learn how to efficiently deploy Hugging Face transformers in real-world scenarios and optimize them for scalability and reliability.
Did you know that deploying transformers in production can amplify your AI capabilities exponentially? However, it's not as straightforward as it seems. In this video, we'll unpack the best practices for deploying Hugging Face transformers in production environments. From tackling deployment challenges to ensuring data privacy, we'll cover it all. By the end of this series, you'll have a toolkit of strategies to optimize and manage transformers for production use. So, let's dive in and transform your understanding of transformers in production.
Deploying transformers in production environments is fraught with unique challenges. One of the foremost issues is the complexity of these environments, which can vary widely depending on the industry and application. Scalability and latency are also significant concerns. How do you ensure that your model can handle a sudden influx of data without suffering performance degradation? Resource management becomes critical here, as transformers can be resource intensive. Furthermore, maintaining version compatibility across different systems and ensuring robust security measures are in place to protect sensitive data are pivotal for successful deployment. Addressing these challenges requires a strategic approach, often involving tailored infrastructure and process optimizations. In production, the size and speed of your transformer models can make or break your deployment. One effective strategy is model pruning, which involves removing less critical parts of the model to streamline operations. Quantization, which reduces model precision, is another technique that can significantly enhance speed without severely impacting accuracy. Distillation, where smaller models are trained to mimic larger ones, is also gaining traction. Balancing speed and accuracy is crucial, and sometimes, hardware acceleration using GPUs or TPUs can provide the needed boost. Optimizing these aspects ensures that your models remain efficient and responsive in real-world applications.
An efficient inference pipeline is essential for deploying transformers in production. The design of your pipeline architecture can significantly impact performance, with well-designed systems facilitating seamless data flow and processing. Batch processing can be particularly beneficial, as it reduces overhead and enhances throughput. To minimize latency, consider employing techniques like caching and asynchronous processing. Handling real-time data requires robust integration with existing systems, ensuring that data is processed and results are delivered promptly. By focusing on these elements, you can create inference pipelines that are not only efficient but also scalable and reliable, meeting the demands of production environments.
To achieve scalability, distributed systems are often the go-to solution for deploying transformers in production. Distributed computing offers the ability to handle large-scale data and processing demands by leveraging multiple machines. Load balancing ensures that resources are used efficiently, preventing any single node from becoming a bottleneck. Horizontal scaling, which involves adding more machines to manage increased loads, is a powerful strategy. Cloud solutions, such as those offered by AWS, Google Cloud, or Azure, provide flexible and scalable infrastructure for running transformers. Managing these distributed resources requires careful planning and monitoring to ensure optimal performance and reliability.
Monitoring and logging are critical components of managing transformers in production. Performance metrics provide insights into how your models are operating, highlighting areas for improvement. Real-time monitoring tools, such as Grafana or Prometheus, enable you to track these metrics continuously. Effective logging strategies help capture detailed information about model operations, which is invaluable for diagnosing issues and optimizing performance. Anomaly detection techniques can identify unusual behavior, allowing for swift intervention. Continuous performance evaluation ensures that your transformers remain efficient and effective, adapting to changing demands and maintaining high levels of reliability. Security and privacy are paramount when deploying transformers in production. Data encryption ensures that sensitive information is protected during transmission and storage. Implementing secure access controls prevents unauthorized access to your models, safeguarding intellectual property and user data. Compliance with data regulations, such as GDPR or CCPA, is essential to avoid legal repercussions. Privacy-preserving techniques, like differential privacy, can enhance data security while maintaining model performance. Regular security audits help identify vulnerabilities and ensure that your deployment remains secure against evolving threats, protecting both your organization and your users.
Managing model updates and versioning is crucial for maintaining the integrity and performance of transformers in production. Version control systems, such as Git, facilitate tracking changes and collaborating effectively. Understanding the model lifecycle helps in planning updates and transitions smoothly. Employing continuous integration and deployment (C/CD) pipelines ensures that updates are tested and deployed consistently, minimizing disruptions. It's important to assess the impact of updates on production environments to avoid unforeseen issues. Having rollback strategies in place enables you to quickly revert to previous versions if problems arise, ensuring continuity and reliability in your operations.
Exploring case studies of successful production deployments provides valuable insights into best practices and potential pitfalls. Real-world scenarios demonstrate how organizations have overcome specific challenges, such as scaling to meet demand or ensuring data privacy. These case studies often showcase innovative uses of transformers, highlighting their versatility and impact. By examining the strategies employed and the outcomes achieved, we can identify lessons learned and best practices that can be applied to deployments. Whether it's a tech giant or a startup, these examples serve as a blueprint for leveraging transformers effectively in production environments. As we've seen, deploying transformers in production requires a comprehensive strategy that addresses size optimization, efficient inference, and robust security measures. Continuous learning and adaptation are crucial in this fast-evolving field. We encourage you to interact with this video by commenting, sharing your experiences, and suggesting future topics. Join us on this journey as we continue to explore more advanced topics in AI deployment. Don't forget to subscribe and turn on notifications to stay updated with our latest content. Together, let's transform the way we approach AI in production.